So now we're going to look at dividing a polynomial by quadratic factor. Higher degrees goes much the same way, but it's increasingly tedious. So we're just going to do a quadratic one. I'm going to do long division, and I'm going to do a synthetic division version. The synthetic division one, you can adapt it to higher degrees, but you still need that leading coefficient to be 1. If not, you have to divide through things. I'm not going to worry about that. Okay, so I'm dividing this thing, and it's probably a good idea to get rid of that leading coefficient anyway. Just whatever. Anyway, so here we go. We've got the long division part. I'll do one step here. So x squared minus 3x plus 5, and I'm dividing into here. So I need to cancel that 4 to the x to the 4th. How do I do that? Well, I need to multiply x squared by 4x squared. So I'll just put that over the x squared term here. And we get 4 to the x to the 4th minus 12x cubed plus 20x squared. And we do a minus sign, like so. So that gives me a 0 here. This gives me a minus 17 x cubed. And then I get, oh, sorry. Nope. Tricky. So the minus sign distributes, right? So it's plus 12 and minus 5, so 7x cubed plus, and then minus 20x squared, right? And then I'm going to need that plus x, right? Now here's how to set it up for synthetic division. We do the same thing we did before, only we're going to have another row. And things are going to get shifted a little, but it's very similar. So we have that top row, 4, minus 5, 0, very important to put in the zeros, 1, and minus 3. So that's the top. On the left, we do the negative of the coefficients. Again, the leading coefficient is 1, and the beauty of this method is, like, because it's 1, a lot of things happen that we don't have to compute, and so we can drop it. So we've just got 3 and minus 5, opposite signs from the coefficients that are there. Now, drop down the 4, just like we did with the other one. And then 3 times 4 is 12. And then minus 5 times 4 is minus 20. It's here. And so this becomes 7. All right? And then you can kind of see some of the elements, right? So this 7 here is this 7 here. This minus 20 is that minus 20 over there. And we've got the 4 and 4, of course, here. And, sorry, too many colors. And the 12 and the 12, right? But the signs are such with a synthetic division that everything is just adding. I mean, there's negatives, so just subtract. But you're not negating these things, right? That's huge. So what's the next step? The next step is, in the long division, okay, I've got a 7x cubed, so I've got to have a 7x cubed. So 7x. 7x cubed. So this is minus 21x squared and 35x. Now again, I negate it. So remember that. So minus 21. So again, this is like just 0, right? And then you get 21 minus 20, so that's just x squared. And then minus 35x, so that's minus 34x. And then we've got a minus 3. Okay, what do we do over on the synthetic division? Well, we multiply the stuff by, we multiply this 7 by the 3 and the minus 5. So we get 21 over here. And then minus 5 times 7, that shifts over to the next column. So that's minus 35. Okay. And then 21 minus 20 is just a 1. And then I just like the synthetic, so I'm just going to complete this. So 3 times 1 is 3, and then minus 5 times 1 is minus 5. And at this point, see, I'm not going to multiply anything more. I don't. It always needs to be this kind of slanty line, right? I've lost the slanty line. So, kind of misaligned here. Let me just shift that over here. There we go. 4 minus 31 is minus 31, and then minus 3 minus 5 is minus 8. Wow, did that correctly. Nice. What about long division? Well, I need to cancel that x squared. So that's just going to be a plus 1. So that's x squared minus 3x plus 5. But I'm negating it to cancel. So boom, boom. And we get minus 31x minus 8. Gotta say, I'd probably make the mistakes with the signs if I hadn't already done it with the synthetic division. It's a pretty sweet system. So, right, so what does all this mean? This means that this, if I call that p of x, that p of x, well, so this translates into, so there's 3 terms, 4, 7, and 1, and include zeros if there's zeros. And so its degree is 2. 4x squared plus 7x plus 1. That's what's on top of the long division thing, right? And this thing is minus 31x minus 8. So the remainder is now a linear factor. That's just how it goes. And basically, either method is computing this. So I want to write the p of x as x squared minus 3x plus 5, and then multiply that by 4x squared plus 7x plus 1, and then I have this remainder minus 31x minus 8. Okay, cool. Let me pause this just for a moment while I compute a new polynomial. Okay, so I have constructed this polynomial. It's got 2 complex roots, 2 real roots. And the complex roots generate this polynomial. So that's a factor. So that's the information that I want to start with. X squared minus 6x plus 18 is going to cleanly divide into that 4th degree polynomial. And I want to show you how that works. So, yeah. So basically, 1 minus 5, 10, 30, minus 36. And then plus 6 minus 18. So flip the signs, the coefficients. Leading coefficient of the divisor is 1. So we can use this. And we just do it. 1, so 6 minus 18. Minus 5 and 6 is 1. So 6 and minus 18. Now we add up these 3 things. 16 minus 18 is minus 2. And so 6 times minus 2 is minus 12. And then minus 2 times minus 18 is 36. Okay, so I'm expecting that to be 0, probably. So, well, yeah, I mean, I guess it's, yeah, clean. See, this is why it's good to do these things. This sum is 0, and this sum is 0. No remainder. That's the point. All right, and so what do we have? We have our polynomial factors as x squared minus 6x plus 18 times So 3 terms here, x squared minus, what are we doing? Plus x minus 2, right? Now, I can try and factor this thing, this one. I'm just going to say that 1 is a factor into that. And so 1, 1, 2, 2, 0. Boom. So then this is x squared minus 6x plus 18 times x minus 1. And then I've got x plus 2 sitting right here. That's what these two things are. Easy peasy. So if for some reason you've got some crazy math person who's like, hey, factor these things, go with synthetic division. Seriously. It's nice. Really easy. Really, really simple. Just drop it down, multiply, do diagonals, add, multiply. Right? What could be easier? So there you go.